A great evening, morning, and afternoon to the lovely audience. The pleasure is all mine to welcome you all again to this Minimac webinar platform. I am Pragati Shvastav from Marketing and Branding team. Today, we will be throwing light on the topic how to perform flushing successfully in lesser time. So, if we talk about flushing, it's crucial to ensure that the machinery and pipe of hydraulic and lubrication systems are clean and free of contaminants. So, let's welcome our today's panelists, Mr. Anshuman Agarwal and Ms. Pulkita Rohila Zaidu.
Welcome all of you for today's session of the webinar. And today's topic is quite close to all of us who are a part of the maintenance and reliability, especially the asset integrity management. The topic is flushing. And for flushing, we have got various myths, challenges, some case studies, which we would like to discuss for the today's webinar. Pragati, if you could confirm my screen is visible.
Yes, sir, your screen is visible.
Thank you so much, Pragati.
Well,
So, lube oil flushing, it's a practice which is very common for most of the lubrication systems and hydraulic systems. And today we would be taking ahead multiple steps towards lube oil flushing. So first we would discuss about pursuit to system purity. We would also have certain myths which are linked to oil flushing. And there are multiple challenges which various customers and various maintenance teams face with regards to flushing. We would be discussing those challenges as well. And before we end the presentation, we would like to give you 4 or 5 cornerstones of oil flushing. And we would like to discuss certain live cases of flushing failures which have happened in past in our knowledge. By pursuit to system purity, what we mean is that you eliminate all the unwanted contaminants and particles from the entire system, from the entire hydraulic system, from the entire lubrication system. And by just cleaning or filtering the oil or the lubricant, you don't achieve the 100% system purity. What you actually need is to purify each and every internal of the pipelines, of cavities, of various components of your lubrication system. So for that purpose, you need flushing. Flushing is basically a sudden gush or high velocity flow of the lubricant through the system components. And this is required to be done through all the components, whether it's pipelines or valves or pumps or heat exchangers. So any cavity or any internal of your entire system needs flushing. There are multiple stages when you perform flushing. Either you perform at the initial stage when your plant is commissioned, or you perform during the maintenance phase. So we would be discussing on what are the time when you need to have flushing. Before we go into the depth of oil flushing, let us discuss about the myths which are prevalent in the market. The first myth is that oil flushing is only a pre-commissioning activity. By this myth, a lot of people agree that only a new project would require oil flushing. But that's not the case. Actually, flushing is a part of your pre-commissioning activity. It's also a part of your shutdown and turnaround activities. Flushing also is required during your breakdown maintenance. Suppose you have a sudden breakdown in your equipment and you need to repair all your parts, you dismantle the parts and you reassemble the parts. Even during those activities, you need flushing. And whenever you plan oil replacement for your entire system, whether you upgrade into a different grade of oil or you change the entire oil, probably because it has got degraded or some other reason, you need flushing. So flushing is not just a pre-commissioning activity, but it's required throughout the life cycle of the lubrication system. The second myth is that flushing is redundant if the rotary equipment was flushed at the factory when it was manufactured by the OEM. So there are a lot of heat exchangers or pumps or valves or other components which come to our project site, and these are assembled together. Various pipeline segments and loops, they are assembled together. And we assume that if all these components have been factory flushed before they reached our site, probably we might not require oil flushing once again at our site. But that's a big myth. So what happens is, at the site, when you build your entire system by interconnecting pipelines and you weld a lot, you have multiple loops. So during welding, during storage, and during other activities of assembling, a lot of debris gets deposited in the internals of your system. And this debris keeps on sitting there till the time you start your system or commission your system. And if you do not perform flushing timely, then this debris actually starts coming off when you start your system and you actually commission it. So there are multiple sites where we have seen that flushing was bypassed, and just because of the reason that flushing was already performed by the OEM earlier. So flushing was bypassed, it was not done properly, and later on they faced problems of debris coming off from the pipelines during the commissioning phase. So this myth actually can lead to a lot of damages during your commissioning activity, because the debris will come off and it would start collecting in your basket filters and strainers and so on and so forth. Myth number 3, oil flushing is a redundant activity if chemical cleaning has been performed. So many site personals or project teams assume that chemical cleaning is good enough, and you can actually bypass flushing if you have performed the chemical cleaning in an efficient manner. But that's not the case, because chemical cleaning actually happens by the user itself. And all these chemicals have a base that is water. So they are performed using water and the chemicals. Now, if you do not perform flushing, there would be traces of water and these chemicals, which would be sitting on the internals of your entire system. And when you actually fill up the oil, charge the oil into your system, and you start it, these chemicals will start mixing up with your oil and they would rapidly degrade them. In fact, we have seen multiple cases at projects where fresh oil was charged in the lubrication system, and as soon as it was charged, it got emulsified. So you can see the pictures below that emulsification happened very fast, and because of this, they could not actually start the project. The reason was the traces of water which were present in the entire system because of chemical cleaning activity. They got started mixing up with the charged fluid or the charged lubricant, and contaminated it immediately. So that's the reason why you need to perform a proper flushing whenever you perform the chemical cleaning activity. Myth number 4 is efficient oil flushing happens at a very high pressure. So many people assume that if the pressure of the system is increased to substantial levels, then you would have a good flushing. But that's not the case. Actually, at high pressure, you perform hydro testing or high pressure testing. You do not perform flushing at high pressures. For flushing, you need high velocity or high turbulence or high flow rate. So as a matter of fact, pressure is different from flow rate or velocity. And that's why you need higher flow rates to perform flushing. Because we will see in the subsequent slides that efficient flushing requires turbulence. And turbulence does not get created because of pressure. It's a very layman term that we use normally. If you increase the pressure, the turbulence will increase, but that's not the case. Turbulence increases when you actually increase the flow rate. By that, I want to say that if you actually want to insert a higher fluid in a smaller cavity at a higher rate, it's actually then when the turbulence is created. If you just fill up a liquid into a space, into a cavity, and start pressurizing it, there won't be any turbulence. There would be just increase of pressure. So this is a big myth that high pressure actually performs good flushing, but that's not the case. High pressure would just help you to check the leakages. It would help you check the integrity of your pipeline, but actually it would not help you in any manner in terms of flushing. But yes, what happens during flushing is a lot of back pressure is created. And because of the larger flow rate going into a smaller cavity, back pressure also is increased. So in order to sustain that back pressure, you do require high pressure for your motor or the pump capacity or power, which you're using for performing the flushing application. So in other words, you can say that for good flushing to happen, you require both flow rate as well as pressure. Myth number five, oil flushing flow rate is decided based on the largest diameter of the pipeline of a lubrication system. Well, that's not the case, because lubrication system is a network of pipelines. There are multiple loops. There are loops which are in series. There are loops which are in parallel. And what actually happens is your flow rate gets distributed into multiple loops and the branch lines and the manifolds. So when you decide a flushing flow rate, you actually need to check each of the branch lines. You need to check if you have some cooler tubes or some heat exchangers. You need to actually check the flow rate through each of the tubes. And only then you can decide the flushing flow rate. So we would be checking that through our case studies in the subsequent slides as well. But as of now, you can just keep in mind that while you are deciding the flushing flow rate, just don't go based on the largest diameter of the pipeline, but you have some more additional points to actually take care of before you decide the flushing flow rate for your system. Myth number six, oil flushing is all about attaining and generating a report of NAS 1638 or ISO 14406. So what are these numbers? These are actually standards for checking the oil cleanliness levels. So these are not standards for checking the flushing efficiency. These are not standards for checking the completion of flushing, but they are just one of the milestones for checking the fluid purity. So while you're using oil for doing the flushing activity, the oil cleanliness is measured using these standards. So many site personnel assume that by checking the NAS quality or ISO 4406 quality, they can actually conclude the flushing activity. But that's not the case. These are actually the secondary tests, which must be performed if and only if the primary test is passed. And what's the primary test? The primary inspection is the mesh inspection. So if you can check on the figure below, and there's a chart which is showing the NAS quality. So this we have actually taken from one of the actual sites where NAS quality was continuously being achieved by the site personals, but the mesh, it was completely dirty, and there were large size particles which are found on the mesh. So why does this happen? This happens because when you do the NAS testing or ISO 4406 testing, these are tested only on a 100 milliliters of sample size. But the mesh inspection happens on the full flow rate, means it happens on the downstream of the flusher. So whatever system purity is to be measured, it should be measured on the downstream of the entire loop which you are actually flushing. So on the downstream, if you have a mesh inspection, it will actually take care of the entire flow rate which is passing through the downstream. And there, if you have particles which are of decent enough a level, as per the API 614 standard, that's the stage when you can actually go for the secondary testing. So I hope myth number 6 is clear that just NAS 1638 and ISO 4406 must not be considered as the milestones, the only milestones rather, for closing the flushing activity. So what are the common oil flushing challenges? We have understood what are the myths. So the next section is to understand the challenges. The first challenge is that oil flushing itself is a milestone activity. So if you have a project where you are doing or performing certain pre-commissioning activity, oil flushing becomes a milestone activity, means the project company or the service provider company would actually get paid against the flushing activity. So thereby, there is some kind of rush towards completion of flushing as fast as possible. And it has been seen that at multiple sites, people just bypass the flushing activity or ignore the exact manner how the flushing has to be performed just because it's a milestone activity, and they want to finish it as fast as possible so that the project can get into the next phase and they can get paid off. So thereby, it is a big challenge as a owner or as a EPC company who has to actually verify the flushing. It's a big challenge. So you need to be a little more vigilant whenever you are verifying or concluding a flushing. You need to be vigilant, and for need to be vigilant, there are certain checklists which are given to you by the standards by your OEMs, which need to be followed. So just take care of the flushing activity conclusion because it's a milestone. So everybody wants to rush. The second challenge is, it's a common phrase actually, which I've heard in the field: oil flushing has to be performed yesterday. So as contractors, as consultants, whenever we ask our clients, when do you want to start this activity? And most of the answers which I receive or my team receives is oil flushing has to be performed yesterday, which means that they have actually lost the timelines and they're too late to plan for the flushing activity in a proper fashion. So it's basically a challenge that it's an ignored activity. Initially, when the projects are planned or they are chalked out, the timelines or the GANs are prepared, during those phases, flushing gets ignored because probably people don't give the right due to the flushing activity. And that's the reason why they miss it out. And later on, when they realize it's already too late. The third challenge is shortage of specialized manpower and equipment. So both the resources are important for flushing. You need manpower who knows flushing, who understands the importance of flushing, who know how to perform it, who know what are the challenges associated with it. So there is a shortage of manpower. We do understand that. Second, there is also a shortage of right machinery, because in the subsequent slides you would come to understand that flushing cannot just happen by your regular lube oil system. It needs certain equipment which are specialized for performing that task. There are certain accessories, there are certain equipment, there are certain resources which you need to deploy at your site, and there is a scarcity. So while there is a scarcity, you need to plan for it. And if you don't plan for it, probably you would be landing up spending more than 3 or 4 times the actual price for those resources. And that's the reason why you need to actually plan the activity in advance, because there is a acute shortage of both resources, manpower and equipment. So these are the challenges. So I believe now I would have certainly sensitized the audience that flushing might be looking as an easy topic for you, but there are multiple challenges associated to it. So whenever you have in your project timelines or in your maintenance schedules flushing as one of the scope of work, you need to actually plan for it. Now let me give you 5 cornerstones of oil flushing. So with these 5 cornerstones, if you make your checklists, if you plan your activities, I'm sure you would not fall into any trap. So the first flushing cornerstone is flushing flow rates, which gives you an answer on what flow rate you require for performing your flushing. For understanding this first cornerstone of flushing flow rate, there's a formula for Reynolds number. So what's Reynolds number? Reynolds number is basically a parameter which can give you an understanding whether you will have a turbulent flow or you would have a laminar flow in your pipeline. So for deciding the flushing flow rate, you actually calculate through the Reynolds number formula. And in the Reynolds number formula, you need to ensure that you have a Reynolds number more than 4,000. The second cornerstone of flushing is fluid viscosity. And for designing the fluid viscosity, again, you refer the same Reynolds number formula, because if you see the formula, there is a viscosity on the denominator, and there is a velocity which is linked to the flow rate. It's on the numerator. So in order to decide what should be your viscosity, what should be your flow rate, you need to refer to the Reynolds number formula. The third one is oil temperature, because temperature would actually lead to changes in your oil viscosity. And it would also lead to certain efficient flushing requirements. Those are called as thermal shocks. We would be seeing all of those in the subsequent slides in much depth. The fourth cornerstone is efficient filtration, because flushing is all about trapping the contamination, and that's why you need efficient filtration as well. And the fifth cornerstone is testing. So, in order to conclude your flushing, you need a good measuring device for testing. So, these are the five cornerstones of flushing. Now, let's go into the depth of each of them. The first one is flushing flow rate. As we have understood that turbulent flow is required, and for turbulent flow, you need a Reynolds number of 4,000 or above. Now, in order to decide this flow rate, as we also talked about this flow rate in one of the myths, you don't take the largest pipeline diameter, but you actually take care of each of the branch lines. So here we have a small diagram which can give you an understanding how the importance of branch lines plays towards flushing flow rates. Because probably if you design the flow rate based on the largest diameter pipeline, what happens when this flow rate gets distributed in around 10 different branches? It gets divided. And when it gets divided, probably you would not get the desired flow rate in the branch lines. So instead of deciding the flow rate across the largest diameter pipeline, you must decide the flow rate across each of the branch lines. They might be smaller in size or diameter, but they might be in large numbers. And when these are in large numbers, you actually get the entire flow rate distributed. And if the flow rate is distributed, probably you won't get the desired minimum flow rate in each of the pipelines, each of the branch lines. And that's the reason why you decide the flow rate based on each of the branch lines. The flushing pump decision is also very important. The flushing pump needs to have subsequent pressure. Why the pressure is required? Not because you want to create turbulence, because as we understood, pressure is not a factor in creation of turbulence. But while you create the turbulence in a small cavity or a small pipeline, you actually incur a lot of back pressure. And that back pressure needs to be sustained by the flushing pump. And hence, you need to have a drive for your pump or a prime mover for your pump, which can sustain higher pressures. And hence, you require higher pressure handling capacity. Fluid viscosities. What we know from the Reynolds number formula that at low viscosities, the flushing flow rate requirements will also lower down, because at low viscosities, turbulence will be created even at a lower flow rates. So in order to reduce the viscosities, you increase the temperature. And for increasing the temperature, as we understood, this is one of the cornerstones. You need to have heating devices on the flushing rig. So as you can see from the first graph, when you increase the temperature based on the viscosity index of your lubricant, the viscosity would be lowered. And as the viscosity would be lowered, a better turbulence would be created in the pipeline. The second benefit of oil temperature variation is thermal shocks. What are thermal shocks? Thermal shocks are sudden variation in temperature of the fluid which is being used for the flushing application. And when the fluid temperature changes, there are expansion and contraction which happen in the pipeline. As there is a difference of coefficient of heat for the debris and the pipeline because of difference of materials, there would be a loosening effect. Whenever you have a variation in temperature, there would be a loosening effect for the debris which is sticking very tightly to the internals of your pipeline. And that's why the thermal shocks are required. Along with the thermal shocks, if you can perform some mechanical shocks using hammering or using mechanical vibrations, Then the loosening effect would also help in dislodging the debris into the fluid or the flushing fluid. So you can see the picture below. There is a pipeline which is due for flushing, has a lot of rust and debris in the internals. After flushing with proper methodologies, the pipeline you can see is as clean as a new pipeline. The next cornerstone is efficient filtration. So why is filtration required? It's required to super clean the entire fluid which you are using for doing the flushing activity. So you require a super clean fluid at the upstream. You require a clean fluid at the downstream. Because when you charge the fluid into your loop, it must be clean. If it is dirty, you are not actually cleaning it. How many of us would actually clean something with a dirty water? We would never do that. We always require clean water for cleaning our houses or our houseware. Similarly, for doing the flushing for your pipeline or your system, you require super clean lubricant. And for ensuring a super clean lubricant, you require a good, efficient filtration. Why do you require filtration at the downstream of flushing? Because after flushing, a lot of debris gets added to the fluid, which is used as the flushing fluid. And this debris needs to be collected before it recirculates in the same pipeline. So you require filtration on the upstream, where you are charging the fluid into the point A of your loop, and you require efficient filtration at the downstream of the flushing loop. And how do you do this filter selection? So as flushing is a time bound activity and it has to be done very fast because there is a project for completion, you actually do the selection of filtration based on the ISO 16889 standard. And for that, you need a good beta rated filter. You also need high dirt holding capacity. So if you use the same filters, which are as a part of your lubrication system, probably they would be not designed to handle that large amount of mud because they are designed for the regular lubrication contamination. They are not designed for heavy mud. So during flushing, you would encounter a very large amount of debris. And for that, you certainly require larger surface area or larger dirt holding capacity filters. So probably you should not go with the system filters, but you should go with external filters for doing the flushing. And the last cornerstone is the fluid testing. So there are three different parameters which you need to follow for fluid testing. The first one is the primary one, which is called mesh inspection. People from the oil and gas industry would know about API 614 standards for lubrication systems. And in this API 614 standard in chapter 3, there is a mesh inspection chart which has been provided. And that chart gives you how many number of debris particles are allowed on the mesh. The second standard is NAS 1638, and this standard follows the testing of micron level particles up to 5 micron levels, as low as 5 micron. The last one is ISO 4406, particulate distribution, and this is again an international standard from ISO. It counts the particles more than 4 micron in size. So there are particle counters which can be used both in online as well as online offline modes for doing the inspection of NAS as well as ISO. So what is the typical flushing circuit? So as we can see, there is an oil reservoir, there is oil pump, then there is a flushing line filter on the upstream, then the entire pipeline which you need to flush, and then you have the return line filter on the downstream, and from there the fluid returns back to the reservoir. So this is a typical flushing circuit which you need to adopt, and this circuit is quite different from your regular flushing system because, as I talked to you earlier, the flushing system is designed to handle large amount of debris, whereas your lubrication system isn't designed for large amount of debris. So you have sophisticated pumps on your lubrication system. You have optimum size of filters on your lubrication system, and probably you would have very low capacity of heaters on the lubrication system tanks. And due to these three limitations, we recommend you to go for external flushing systems. And these external flushing systems would have a pump which would be sufficiently designed for large amount of debris. They would have filtration system or filter vessels which can carry a large amount of debris, and they would have heating systems as well in order to provide you with the thermal shocks heating. Some of the examples of flushing systems which Minimac as a company offers. So you can see on the top, these are large size flushing systems of around 4,000 liters per minute. Now that's quite huge, 4,000 liters per minute. And then there are hydraulic flushing systems, which are smaller in flow rate, but can have larger velocities and larger pressure sustenance capacity. The same flushing systems can be designed for compatibility with chemical cleaning as well, so that you don't have to carry two systems at the site. So these can be designed in stainless steel bodies, and those can be used for performing both chemical cleaning and then flushing activity. The configurations which are available are compatible with ATEX standards for explosion proof environments or offshore environments, and they are CE marking as well as DNV 2.7-1 offshore certified skids. Because we understand you would have to handle these skids at sites which are project sites, and there are compliance requirements. So the skids are compatible to the required certification standards. Now, coming to certain case study discussion. So the first case study which I want to discuss here is about a gas compressor flushing at one of the projects in Oman. And what happened at this project was the challenge that heavy sand debris was found immediately after the startup activity. And flushing was already concluded by a reputed contractor. But as soon as the plant was commissioned and the system was started, the gas compressor system started experiencing a lot of sand debris. Why did that happen? So the diagnosis was that the flushing flow rate was inadequate for the heat exchanger tubes. Now, no one actually took care of the heat exchanger because of the very reason that heat exchanger was already factory flushed by one of the reputed heat exchanger manufacturers. So no one took care about the heat exchanger. But they also forgot the fact that these heat exchangers were subject to a sandy environment for a very long time while they were kept in the yards. And probably the ports were open. So a lot of sand got deposited in the internals of the heat exchangers. And as they were not flushed during the plant pre-commissioning activity, as soon as the system was started, the entire sand which was deposited in the internals of the heat exchanger, it started getting off and collected in the gas compressor lubrication system. So what is the solution? Actually, a special need is required for heat exchanger flushing, because heat exchangers are typical systems which have multiple tubings. Though the tubings are of just 1 inch or 1.5 inch in diameter, but they are multiple in number. In few cases, they are around 200 or 300 in number. And this actually increases the entire flow rate through the heat exchangers. Now, what happens is the fault, what people do is they check the port size of the heaters, which are normally 4 inch. They design the flushing flow rate based on the port sizes of the heat exchangers. But actually, heater is a parallel bundle of multiple loops. And you forget to calculate the flushing flow rate through the multiple loops of the heat exchanger. So we have actually checked that when you have to flush an heat exchanger or ACHE, which is air-cooled heat exchanger, which has multiple loops, you need to actually go to a flow rate level of around 4,000 liters per minute. Minimum is 3,000 liters per minute. So unless you do that, you're not sure about the heat exchanger flushing. The second interesting fact what we found at the site was that heat exchangers, the loops or the tubes do have certain turbulators. These are called tube turbulators for increasing the efficiency of heat exchanger. But when you do the flushing, these turbulators need to be handled very delicately because they are like mesh, they are like net. And when you perform the flushing, they actually start trapping the debris inside the turbulator wires. And these debris which get trapped in the turbulator wires, they start getting released when you close your flushing or conclude your flushing. So you need to actually perform the flushing without the turbulators. Then you again need to perform the flushing with the turbulators before you actually hand over the system for commissioning. So turbulators need to be handled very cautiously whenever you find them in the tubes of the heat exchangers. The second case study which I would like to discuss here is from another project in Oman, which was from BP, where a high viscosity lube oil was being used for flushing. And as the system was designed to handle high viscosity lube oil, even the flushing was being performed by high viscosity oil. So the challenge was that even at the 2x or 3x of the lube oil pump flow rate, flushing was not being achieved in efficient manner. What was the solution? So the solution is that flushing flow rate should not be designed based on the regular lube oil system pump, but flushing flow rate should be designed based on the Reynolds number calculation. And if you see the Reynolds number formulae, you have viscosity on the denominator. So if you have a higher viscosity, that would actually tend to reduce the Reynolds number. So in order to have a better turbulence, you need to have better flow rate so that the compensation of the higher viscosity can be done through higher flow rates. The third case study is from Central Asia, from Kazakhstan. And the challenge here was that the ambient temperature of the project site was sub-zero. And due to this sub-zero temperature, the entire system was working on a very low temperature level. And because of this low temperature level, the fluid viscosity, the standard fluid viscosity, although it was around 46 say CST, because of the sub-zero temperatures, the fluid viscosity shot up. The system which was being used out there was not designed or tropicalized for the extra provision of heaters. And that's why the flushing flow rate was not getting achieved. So Minimac team approached the site and they provided extra heaters system. So if you can see here on the tank, beside the tank, you have multiple heaters banks, and the similar heater bank is on the opposite side as well. So these heater banks actually help you in, yeah, this one. So these heater banks can go up to 160 kilowatt, or in some cases even you can go up to 200 kilowatts. And they would help you to handle the sub-zero temperatures of your site. So tropicalization of a flushing skid is very important when you have global fleets. If you are a large company, a global organization, and you have global fleets, so before you deploy a particular system or a skid to your site, you need to check the compatibility of the system for your environment, for your ambient conditions, and only then a flushing system must be deployed. The next case study is basically from a steel plant in India. And this steel plant was having a turbine driven blower for the blast furnace area. The problem which was occurring out there was flushing was already completed because the contractor had achieved the NAS 1638 level, and also ISO 44006 level. But still, the entire lubrication system was experiencing a lot of debris in it. So the entire project team, the owner company, they were confused. Already NAS was being achieved, but still a lot of debris was being experienced. So what was the problem and what was the solution? The problem was that, as we discussed, one of the myths, NAS standards and ISO 4406 standards, they can't be the final decision maker parameters for concluding the flushing, but you must perform the API mesh inspection. So when the Minimac Systems team approached the site and we started our diagnosis, we first installed these mesh inspection screens on the entire system. And you can see the level of debris which was getting collected. And when these system was being flushed, it was flushed by a high velocity flusher. And once this flusher concluded the job, the mesh inspection was found to be as clean as shown here. So basically, when you do a mesh inspection, you assure that the entire loop of the pipeline has got cleaned of the debris, and then you can perform the NAS standards. So interestingly, the NAS standards remained the same throughout the entire flushing, but the mesh inspection screen got cleaner and better as we concluded the flushing activity at this site. So with these four case studies, the cornerstones discussed and the myths discussed, I hope I have sensitized the audience, and at least we appreciate the fact that flushing is the first step of machine reliability, and it is no more an option. So you need to make it mandatory for all your sites. And if you do flushing in the best manner, in the most efficient way, you actually achieve the first step towards machine reliability. So before leaving out, I would like to give you certain standard names which are linked to flushing. So there are ISO standards, there are ASTM standards, there are MIL standards. Then there are standards from the OEMs, like General Electric has got their turbines for which they have a standards. And then there are standards from solar turbines, which are again very popular in the gas turbines. So you can search for these standards, you can seek your help from the OEMs, and be based on these flushing manuals, based on the standards used for flushing, you can decide your own statement of working or SOP, and then you can actually do the flushing. So looking forward to your presence in the next webinar. Thank you so much for attending the webinar today. Thank you so much, Pragati. So over to you, Pragati.
Thank you, sir. It was a very great interactive session, and all the whole presentation was very nice. So we are coming up with the next webinar on the topic General Lubrication System on December 16. I hope to see you all again. The joining link is in the chat box. Kindly register and book your seats in advance. We have successfully completed 12 webinars. You can get all the webinars videos on our YouTube channel. If you don't want to miss out any updates, do subscribe to our YouTube channel. Now, I would like to request the panelists to please switch on their audios and videos. Uh, okay, you all are here. So let's start with the Q&A session. So the very first question of the evening is from Mr. Sharma. So I would like to ask this question from our respected panelist. During flushing, what should be the velocity of the oil Normal lubricant pump can be used for flushing. Actually, I think there are two questions. So the first one is during flushing, what should be the velocity of the oil?
Uh, am I audible, Pragati?
Yes, sir, you're
Yeah.
audible.
So, as we discussed during the presentation, that velocity of the oil is decided based on the Reynolds number, and there's a formula of Reynolds number where you need to ensure that Reynolds number is 4,000 or above, and based on that you decide the velocity. And second is the normal lubricant pump is normally not used for flushing. There are two reasons. The first reason is that the flow rates of normal lubricant pumps are short of the desired flow rate for flushing. So that's why you cannot use them. Second, the normal lubricant pumps are very sophisticated. They are designed for lower levels of debris. So if you use them for higher levels of debris of flushing, probably you are subjecting them to a very worse scenario of running, and you would reduce the life of your normal lubricant pump. So it is better to avoid them and have a flushing system in place, because probably the external flusher entire cost would be less than the price, much less than the price of your lubrication system. So it's better to have external flushing systems and use those flushing systems for multiple flushing applications throughout your project.
Okay, thank you, sir, for your answer. And I can see there are many questions. Thank you to the audience for asking so much good questions. So we are moving to the next question. Uh, it is asked by Mr. Islam. So the question is, explain varnish potential and how to remove it.
Okay, thank you so much, Mr. Islam. So varnish is a very common thing which is found in the lubrication system, and varnish certainly has a big topic of discussion which we probably did in a previous webinar. But as you have asked the question on how to remove it, so varnish is a sticky substance or unwanted product of the lubricating oil, which gets deposited on the internals of your entire system. It gets deposited on various sophisticated components like valves or the pumps or the internals of your pipeline, and more commonly found on the base of your tanks. In order to remove the varnish, which is very lethargic in nature and it's highly sticky to the surface, it's like a hard surface which has got created a secondary surface to your system internals. So in order to remove it, there are certain methods. One of the methods is flushing. But if you can't do flushing for your system as you cannot shut it down, there are methods for removal of varnish which are known as uh, SVRs, where you actually use certain equipment which are based on ion exchange technology. And these ion exchange technologies can be used for removal of the varnish from your lubricating oil. Although it's a gradual process, but it's something which can be done without shutting your system down. Because for flushing, you need to shut down your system. And if you don't have that much of time, you can certainly not do the flushing. So there are two methods. One is ion exchange for removal of varnish, and the first method is, of course, flushing.
Okay, thank you. So moving to the next question that is asked by Mr. Chattopadhyay. And the question is it true that higher the temperature, higher is cleaning?
Yeah, so when you increase the temperature, as we discussed, you reduce the viscosity. And if you reduce the viscosity, the Reynolds number also increases, because viscosity is on the denominator when you calculate the Reynolds number. So when viscosity goes down because of increase in temperature, you actually increase the Reynolds number. By increasing the Reynolds number, you increase the turbulence through your pipeline. And thereby, you can achieve a better flushing when you reduce the temperatures. Increase the temperatures, reduce the viscosities.
Okay. So the next question is asked by some anonymous attendees. So the question is, what will be the filter size in micron to get the NSA level 6?
For NAS level 6, you actually go down to microns of 3 micron. But just by micron rating, you can't ensure NAS. You also need to have a good efficiency of the filters. So if you are planning for filters which are 3 micron, they must be rated for beta ratio, and the beta ratio minimum of 200 is required. Apart from just one filter of 3 micron, you also would need multiple stages, because if you actually have just 1 micron of 3 level, you would load that very fine filter with a lot of debris. So in order to have a longer life of your filter, you need to have stages of filtration.
Okay, sir. That was a fantastic answer. So the next question is asked by Mr. Novianto. So there is a reference: if our oil is clean, it will extend the life of the components for how long?
So I believe your question, Mr. Nuvianto, is related to oil filtration and oil purification. And the question what you have asked is a very interesting one. What will be the life extension? Frankly speaking, there has been a thought around that oil is filled for life, and oils don't have any aging because oils are perpetual. But there is a rider to it. The rider is that the oil needs to be purified to super clean level always, not in an intermittent fashion, but in a regular fashion. So if you have proper filtration and purification systems, then you can certainly have an extension of your oil life. Practically, it's not possible to have indefinite life, because probably there would be some mistakes which we would do while we are experiencing our purification program. But normally it has been seen around 5 to 6 times of oil life is achieved. If you don't do the purification, probably you would have a life which is much lesser than the design life. So if you have filled your oil for 1 year, and if you do not perform purification, if you do not perform the regular reliability activity on your oil, and then your life of oil would be much lesser than that 1 year designed life.
So Anshuman, if I can add something to this answer to develop on this is I think we should not be very concerned with how we can extend the life of the oil, but by cleaning the oil, what we are doing is we are extending the life of our machines.
Very
And
true.
what we have seen is our machines and their parts, like their O-rings, their seals and all of that, they go off very quickly because we have contaminated oil. So if we are keeping our oil or the lubrication system healthy, we are not only extending the life of the oil, but the bigger prize or the bigger incentive of keeping the oil clean is the health of our machines. So we are gaining in terms of reducing the wear and tear and then the maintenance. Also, if we consider time as money, then lesser the downtimes on our machine by keeping them healthy, the more money we would be saving. So I think that I think sums up what Mr. Novianto has asked over here.
Sure. Thank you so much, Pulkita, for adding that thought.
Thank you, ma'am and sir, for your answer. So the next question is by Mr. Ahmed, and the question is like, what mesh size when oil flushing?
I believe Mr. Emma wants to know what mesh size they should use for flushing. It's a kind of a repeat question, as we discussed about the micron rating. So you can go for reduced micron rating. You can start it from 50 micron, then you can go for the second stage at 10 micron or 20 micron, and the final stage as 3 micron. So in stages, when you do the filtration during the flushing activity, you actually achieve efficient filtration as well.
Okay, so the next question is asked by Mr. Richman, and the question goes like, what's the best procedure for flushing contaminated lube oil from a compressor?
So the procedure, I think we have discussed a lot. I mean, various cornerstones, the various myths and challenges. So by procedure, if you want to know the exact method statement, method statement is based on the OEM of the compressor. Normally, these method statements are common. And as a part of our presentation, there was a last slide where we talked about various standards and manuals by various OEMs and the standard organizations. So if you have a compressor and if you have a lube oil system associated to that compressor, you need to refer to the manual which has been provided by the OEM of that compressor or the lube oil system. And there you would find the entire method statement of how you need to perform the flushing. But take my word, all these method statements, manuals, and standards, they all talk about the same 5 cornerstones which we discussed during our presentation today.
Okay, sir. So the next question is, before oil flushing, it is asked by Mr. Kumar, and the question is, before oil flushing, is it required to do some mechanical cleaning or card before board flushing?
So basically what you do is, Mr. Kumar, before you actually take up flushing, you perform chemical cleaning activity. And what you have mentioned here is mechanical cleaning. I believe you are talking about the components which are accessible to us. So if you want to perform the flushing on a tank surface, internal surface, then yes, you can perform it using certain mechanical devices and instruments. Once you have performed mechanical cleaning, you have removed the visible uh, dust or visible deposits on the internals, then you can perform the flushing using an equipment. But for those components which are not accessible, how do you do that? In oil and gas industry, there is a common phenomenon called pigging. And by pigging, what you do is you pass a pig which goes through the entire piping at a very high flow or pressure. And thereby it would do the mechanical cleaning parts. So if there is a stubborn deposit on the internals, probably you would have to start your flushing not by oil but by pigging. Then as a second stage, you can go with certain air or you can go with chemical cleaning. Then you do the dry air blowing. And after the dry air blowing, the final thing what you do is flushing. So flushing, as we talked about, is a milestone activity. By milestone, I mean to say it's one of the last stages for preparing your entire system for the next phase of commissioning. So yes, there are other stages before flushing as well, which we talked about just now.
Okay, sir. So the next question is asked by Mr. Gajpal, and the question is, how do you flush water out of a hydraulic system?
So when you have water in a hydraulic system, it would not be present as water, but probably it would be present as emulsified oil in hydraulic systems. And how do you see that? You see that by a change of color of your oil. Normal oils are transparent, they are golden in color, but when you have water contamination in the hydraulic oil, it changes to white in color. And this is actually emulsification of the oil. For removal of this emulsified content of water from the oil, there are methods called as vacuum dehydration and coalescer techniques. In some of the previous webinars, we had discussed about these techniques. So if you could follow our YouTube channel, you can find about low vacuum dehydration techniques and how they perform. I would request the admin to share some of the links on how low vacuum dehydration systems work on the chat box.
And also, before we go out for flushing out this water from the hydraulic system, I think something that needs to be appreciated is what is the source of this water getting mixed with the oil. We have seen such incidents in the past wherein we were continuously putting oil through those vacuum dehydration, and still the water source was not arrested, and that's why the desired results were not coming. And when our team actually went on the site, site, they first arrested the root cause of that water, and eventually we saw that the entire lubrication system improved. From our experience per se, this is something that we should all do at a field level. That try and arrest the source of the water before we go out for the remedial activities.
Okay, thank you, ma'am and sir. So the next question is asked by Mr. Thanaraj. The question is, what is normal acceptable levels for the hydraulic oil after flushing NMAS and ISO?
Pulkita, you would like to take this question?
No, I guess Anshuman, you can take it up.
Okay, no problem. So for hydraulic systems where you have multiple servo valves and proportionate valves, you certainly need to go for a very fine level of NAS and ISO. And normally the ISO and NAS levels, ISO is 14/12/10. And for NAS, it's around NAS 4 or NAS 5. These levels are normally mentioned on your manual of the hydraulic components. For example, if you have valves, for example, companies like Moog and Parker, they do define the level of NAS that they require for the hydraulic components. Also, I've seen manuals of companies like Rexroth and Eaton and Hydac. All of them, when they design a power pack for your hydraulic system, there is a NAS level which is already predefined, and that normally varies between 4 to NAS 6. For hydraulic systems, we normally follow the NAS standards because hydraulic systems are following the aerospace standards. For lubrication systems, mostly we follow the ISO standards.
Okay. So the next question is asked by Mr. Michael, and the question is, what should be the viscosity of the lubricant for flushing?
So for viscosity, as such, you can go with any viscosity. You can go with low viscosity as well as with high viscosity. We discussed a case study where flushing was performed for high viscosity oil as well. So for example, if you are performing flushing for a gearbox or a lubrication system, which will have a 220 or a 320 grade of lubricant, uh, and if you perform the flushing using a different viscosity of fluid, the challenge which remains is that you have to evacuate the system once the flushing has been performed. And how do you do that? You cannot do that with air, you cannot do that with any other chemical, because that would again remain in the system. So it's always better to perform flushing using the same fluid which the system is designed to handle. And that's why decision on viscosity is not always that we can take independently. We need to go with the viscosity which is compatible for that lubrication system. But in order to decide the flow rate, which is in our hand, we can actually go ahead with higher temperatures. So if it's a higher viscosity, you can increase the temperature, go down, so that you can handle the flushing with much lesser flow rates. So there is a trade-off which you need to do between the viscosity and the flow rate. If viscosity is high, the flow rate also needs to be high. If the viscosity is low, you can actually do the job with a lower flow rate as well.
Okay. And the next question is asked by Mr. Alex. The question is, what is the cause of oil foaming and how can it be removed from the lubrication system?
Foaming is a very common thing which happens in a lubrication system like a turbine or related equipment, even compressors. We have discussed about foaming in past as well, where one of the prime causes of foaming is the starvation. If you talk about the chemical changes which happen in the oil, the degradation related changes, so foaming does happen when there is water or degraded products in the oil. So this answer is not very simple, but the solution I can tell you is very simple. The solution to foaming is decontamination of your oil, reconditioning of your oil. Probably the oil is losing its lubricant properties, and that's why the foaming has increased. So you need to take care of purification activity, and you can go ahead with better filtration system or better dehydration system for your fluid. Thereby, you can handle the foaming related problems of your lubrication system.
Okay, sir. So the next question is asked by some attendee, anonymous attendee. And the question is, does flushing remove varnish?
Yeah, as we discussed in one of the previous questions, for removal of varnish, you can go ahead with flushing, but I'll repeat it that you need to shut down the system. If you want to perform flushing, you need to shut down the system. So there's another way which you can use for doing the removal of varnish, that is ion exchange.
Okay, sir. So the next question is asked by Mr. Amir, and the question is, what is the complete calculation for flushing?
So we had seen in the presentation there was a Reynolds number formula, and that Reynolds number formula is directly proportional to the Reynolds number is directly proportional to flow rate, and it's inversely proportional to the viscosity. So with these two factors taking prime importance in that, the third one is the density of the fluid which you use. So all these three parameters together, when put into the Reynolds number formula, you keep the Reynolds number as 4000 and above, and based on that, you calculate the flow rate of flushing.
Thank you, sir, for the answer. And the next question is asked by Mr. Mustafa. And the question is, should we bypass valves during flush?
That's actually a very interesting question. And this is something which I recently incurred in one of the refineries in India, where this was a DCU system. And the DCU system of a refinery has a lot of valves, which are costly valves. And there, the system was being flushed by the existing company without removing the valves. And what was experienced is that during flushing, the entire pipeline debris got deposited in the internals of valves. So if you do not bypass the valves, you actually subject the sensitive or sophisticated valves to a very high level of debris. So flushing primarily is a pipeline internal cleaning activity at site. Valves are sophisticated components and they don't have much of surface area in the internals of the valves. For flushing the valves, you actually perform flushing at the last phase. So first you do the flushing of the pipeline loops by bypassing the valves. Second, you do the flushing of the heat exchangers and other large sized components by bypassing the valves again. And once you have ensured that the pipeline is clean, the heat exchangers are clean, the other large sized vessels like filters, heaters, they all are clean, only then you charge the valves into your flushing loop. Otherwise, what will happen is the entire large amount of debris from these huge vessels and huge pipelines, they would get deposited in the valves, and you would actually reverse the objective of flushing. So while we have a plan of removal of debris from the system, we would be unintentionally adding a lot of debris into the valves. And then that would be an even major task of flushing the valves individually, because probably you would have to dismantle the valves and then you would have to clean up the debris manually, and only then you would be able to achieve the flushing in the valves. So in order to avoid all these inconvenience, it's better to bypass the valves, which is called as a looping activity or jumper installation activity at the site.
Okay, sir. So we will take the last question for the evening. And the question is asked by Mr. Manoj. So the question is, flushing with supplied pump possible in lube oil skid?
I think this is a repeat question. We already answered it. So
Okay,
probably you can take another question.
okay, sir. Sure. How the question is asked by Mr. Krishna Murthy.
Yeah.
The question is, how long the flushing should carry on for a given system Any formula or thumb rule?
Yeah. So there's no formula to it, but yes, there's a thumb rule. The thumb rule is the milestone of flushing gets ended when you achieve the desired cleanliness level on the downstream of flushing. So what you need to do is you need to test the debris level in your fluid. And the debris level in the fluid is tested by three methods. The first one is mesh inspection. The second one is NS quality testing. And the third one is ISO 4406 testing. So with these three different levels, you can understand whether the fluid which was used for the entire flushing, whether it has been purified or not, whether any additional debris is getting added to the fluid. If yes, then you have no other choice but to continue with flushing. But as soon as you find that multiple inspections, like two or three successive inspections, do not have substantial amount of debris on the downstream, you can conclude your flushing successfully.
Okay. Thank you, sir and ma'am, for answering all the questions. So now, I hope your question has been answered, and if not, don't get disheartened. We will be sharing the FAQ document with all the answers shortly via all the social medias. And thank you for being such a great audience. I'll hope I'll see you all again in our upcoming webinar that is on December 16. You can also join our global WhatsApp community of lubrication talk, and do not forget to register to our website for regular updates. We are keen, and we keep posting interesting technology based articles on our website and via different social media platforms. You can, if you want, you can drop your mobile numbers in the survey form for being the part of our global community, that is lubrication talk. And do not forget to register for our upcoming webinar that is on December 16th. And so thank you for being such a lovely audience, and thank you respected panelists for the interactive webinar session. Hope
Thank
to
you,
see you all
Pragati, for
again.
having us on the panel this evening. And thank you to all of you who joined and participated interactively by posting their questions. So thank you so much.
Thank you and have a very nice day or nice evening ahead. Bye bye.
Bye everyone. Thank you and good night.